In this lecture, we are going to look at input buffering, which is a way by which we can speed up the process of compilation of a large source program. So we look at the techniques by which the task of processing the input program and identifying the lexemes and classifying them into tokens is considerably speeded up with the help of buffering. So now the question is, why do we need input buffering, or why do we need buffering? Because sometimes, if we can recall, in certain programming languages, we may have to look at only one character. Suppose I look at the symbol plus, okay, I know that this is an operator, okay, but the same language can also contain an operator like this, which is plus plus. This is also an operator. So by simply looking at one character, I cannot say that this is a particular lexeme, because this is also a valid lexeme, this is also a valid lexeme. So both are valid lexemes. So I need to look at more than one character at a time in order to find out to which lexeme or to which token class it belongs to. And for this, I need to read more than one character of the source program at a time. So for this, we have something called a buffer. So the buffer is nothing but, we have a buffer. So this buffer, it is nothing but a space in main memory. So your source program is there in the disk. Okay, it is there, it is stored in the hard disk. This, when the compiler or the lexical analyzer wants to perform its task, it has to fetch the strings that are there and put it into main memory. And after that only it can do the processing. So the buffering process allocates a block of memory locations where the strings will be fetched and stored. So usually what happens, you read one character from the disk and then you do the processing. But as we have seen here, using a single character and identifying the token is not possible. You may have to look forward. So in such a situation, you need to look at more than one characters at a time. So for this, you need a buffer of size greater than 1. So what is done in input buffering is that two buffers are taken. So here I have buffer 1 and here I have buffer 2. Each of these buffers is of size n. And what is the value of n? The value of n is same as the size of one disk block. Size of a disk block. So usually it will be 4096 or say smaller than 2048. So something like this. So n will be the size of a disk block. So using one read operation, one system read operation, you can read the entire disk block and put it in your buffer. So two buffers are used. One is of size, both of these are of size n. So together at any point of time, you will have twice n number of characters from the source file. And if you have less than twice n number, then a special symbol called the, let me use a different color, called the EOF symbol, end of file symbol. This is a special symbol which will denote that there are no more input characters to be read. So the last character of the file would be EOF. All right. So coming back to our buffer. So here it has got some locations. All right. Here also it has got some locations of same size. All right. And let me just rub this. So as the data is read from the hard disk to the buffer, it will store the character something like this. So this is our statement E equal to MC square. Now you see this symbol. This particular symbol that is star star. In Fortran language, this represents the power of symbol. But single star also means multiplication symbol. So just by looking at this symbol, I cannot make a decision as to whether this is your multiplication symbol, or it is, I have to look at two more or one more character, then I can decide that this is the power of symbol. Okay. So to do this, we have two pointers which are being used. So two pointers being used. What are these pointers? The first pointer is known as the lexeme begin. So lexeme begin, it marks the beginning of the next lexeme which is being discovered. So if I go back here, if let's say I want to find out this particular lexeme, I've already identified up to C. I want to find out more, then the lexeme begin will point to this. Lexeme begin. So I'm trying to identify whether this symbol here, it is lexeme or not. So lexeme begin will point to the beginning of this. And then I have another pointer which is called the forward pointer. Another pointer called the forward pointer. So the forward pointer, initially it will start with lexeme begin, but it will keep on moving this side, keep on moving in this direction till it finds the end of the lexeme, till it has recognized a valid lexeme. So initially it was here, initially forward was here, then it moved to the next one. Okay. If it was multiplication, then here it should have found a number, but it did not find it, so it moved on again. So it has moved here now. So currently forward is here. So lexeme begin is here. Again, just to make it clear, I'll use a different here. So here lexeme begin is here and forward is here. All right. So now the difference between the two, this will give me a valid lexeme. Okay. So when forward cannot, it has decided that it has found a token, it will not move any forward. So these two are the two pointers which we have used. Lexeme begin marks the beginning of the next lexeme, and we have forward which scans ahead until a pattern match is found. Now, how does these two pointers take care of, there are two things which it has to take care of. One, it has to take care of the character that it is reading currently, and it also has to keep track of the end of the buffer, whether it has reached the end of the buffer. Like, again, if we just go back here, this buffer, forward will keep on moving in this direction. So once it is here, it cannot move any further because it has reached the end of this buffer. So what it will do, once it has reached the end of this buffer, it will move to the beginning of the first buffer, the second buffer. Similarly, forward can also reach at the end of the second buffer. So once it reaches the end of the second buffer, it will move to the beginning of the first buffer. So that's why it is, you can think of these two buffers to be linked in the form of a circle. So it moves there in this manner, rotating in this manner. Forward will move. When it reaches the end of the first, it will move to the beginning of the second. When it reaches the end of the second, it will move to the beginning of the first buffer. Once it reaches the end of the first buffer, the second buffer will be loaded. All right. And then once it reaches the end of the second buffer, the first buffer will be loaded. So alternately, the two buffers will be loaded. Now, at any point of time, two things, like I said, the pointers will have to keep track of. One is what is the character read and whether it has reached the end of the buffer. So to make this process faster, okay, or to make this code more efficient, what is done is that some special characters called sentinels are used. So a sentinel is like the end marker of the buffer. It will mark the end of buffers, end of the buffers. All right. So what better symbol than EOF to mark the end of the buffer? So we will use this symbol as the end of the file. The end of the file, this symbol, we will use it as a sentinel. So again, if I just draw the same buffers, okay, this is the first buffer and the second buffer. So I have something like this, E equal to M into, now here instead of here, you will have a special marker EOF. Here also you will have a special marker EOF. So this two, this one here and this one here, these two are known as your sentinels. The sentinels will tell you when to load the next buffer. Okay, if you have reached the end of the file, then, or you have reached a sentinel, then you have to load the next buffer. Also, another place where we saw this EOF was here. Okay, when something like this, MC squared, then EOF again. So here, this also acts as a sentinel, but in here, in between the buffer, before it reaches the end of the buffer, if we get EOF, this indicates that there is no more input to be processed. So if we look at this code, okay, you can see this code, it tells us the how the forward will move, how the forward pointer will keep on moving. So you can see out here, we have switch forward. So we are looking at this case of a sentinel. So EOF, case EOF. So if it is end of file, it may mean three things: end of first buffer, end of first buffer, end of second buffer, or end of the input. So if case end of file, so if forward is at the end of the first buffer, then what we have to do? Reload second buffer. We'll reload second buffer, and forward will be pointing to, or it will move to the beginning of the second buffer. Otherwise, if it is not at the end of the first buffer and you get an EOF, then the forward is at the end of the second buffer. Then we reload the first buffer, and beginning, we take forward to the beginning of the first buffer. If it is neither this nor this, then, and you encounter EOF, it means that you have reached the end of the input. So what do? You have finished parsing the entire, or not parsing, you scanning the entire program. So you terminate the lexical analysis. So you have a break. And now this is just a code segment. So if for the other case characters, you have different cases. So if it is plus, if it is multiply, if it is something else, so these are the cases for the other characters. So this term here, you can see look ahead. Look ahead means how many characters you are going to scan before you can decide whether it's a valid lexeme or not. And we have seen in our example that it is not possible to determine by looking at just one look ahead. You have to look for, you may have to look for more than one character. And this is where buffering comes into the picture. So that was all about input buffering. Now in the coming lectures, we will see more where these two pointers and this buffering will be working in action.